In this lesson, we're going to be covering inverses of functions, but in order to start talking about inverses, we're actually going to start by finding the definition of what is a one-to-one function. So the first thing we're going to find out is that only one-to-one functions have inverses, so that's very important. By the end of today's lesson, we're going to learn how to find the inverses of functions, but we have to keep in mind that we can only find inverse functions for functions that are what we say one-to-one. In order to figure out if a graph is one-to-one, we do what is called a horizontal line test. In the previous lesson, we talked about the vertical line test, but we use that one to determine if something's a function or not. Once we determine that something's a function, then we're going to use the horizontal line test to determine if it's one-to-one. So the way this is going to be done is we're going to create horizontal lines on a graph, and if a line intersects the graph more than once, then it's not one-to-one. And just like I said right now, we're still going to be using the vertical line test, but if a graph passes the vertical line test, that means it's a function, but then we're going to apply the horizontal line test to determine if it's one-to-one. So let's go ahead and do some problems here, right? So we have 4 graphs and we're going to have to determine if they're one-to-one. So like I said, the first thing we're going to do is that we're going to create lines to see if it's a function, first of all, right? So if I draw a bunch of lines, this one passes the vertical line test, so that means it is a function. But the question is it one-to-one? So in order to see if it's one-to-one, I'm going to have to create now horizontal lines. So if I create a horizontal line, you're going to see that any line that I draw is only going to intersect the graph once. So if you see it just intersected once. So this one is one-to-one. Okay, so if you notice, now we have to apply 2 tests, the vertical line test and then the horizontal line test. Let's go ahead and try the next one. So for the next one, again, the first thing you want to do is check, is this even a function? So if I draw a line, it looks like it's passing, right? Because it only has 1. But if I draw a line here, look what happened. It intersected more than once. So since it doesn't even pass the first test, so this one's automatically no. It's not a one-to-one function because it's not even a function at all because it didn't pass the vertical line test. All right, so let's go ahead and try the next one. This one should be easy, right? Look at that. I make a line, it intersects at 2 different points. So this one is no, right? This one is not a one-to-one function. Again, because it's not even a function. Now, the last one here, we draw lines. It passes the vertical line test, right? All of these lines just intersect once. So I'm going to erase that. Now we have to do a horizontal line test to see if it's one-to-one. So all of these lines here just intersect one time. So that means that this one would be a one-to-one, right? Because I already checked the vertical line test. It's a function, and then the horizontal line test determines that it is a one-to-one. Okay, this one is not on your notes, but let me go ahead and just give you an example of a different scenario. So let's pretend, and I'm so sorry about my terrible picture here, but let's pretend we have something like this, right? If you have something like this, let me go ahead and just see if I could change the color real quick. This one, if you draw vertical lines, this one is a function, right? Because they just intersect once. So this would be an example of something that is a function, but if I draw a horizontal line, it intersects more than once. So this one, I just wanted you guys to see this. This is an example of something that is a function since it passed the vertical line test, but it would not be one-to-one since it failed the horizontal line test. Okay, so that's just a little example you might see on your homework, just so you don't get lost, right? So if you saw, we have scenarios that are not functions, they're not one-to-one, and then we have examples that are functions and are one-to-one, and then this is an example of something that is a function but is not one-to-one. All right, since we already know which functions are one-to-one, now we're going to see if we could draw inverses of functions. This one's pretty simple, but you do have to follow the following steps. So the first thing you're going to do, if you're presented with a graph and they tell you, hey, I want you to find the inverse of this. First thing you're going to do is that you're going to write down important ordered pairs. And by important, I mean ordered pairs that are in the graph or that are pretty ordered pairs, such as like 2, 3 or 5, 7, not ugly ones like an ordered pair that falls between 2 numbers and has a decimal. So we're going to choose important and pretty ordered pairs. Once you create all your ordered pairs, all you're going to do is just interchange x and y. And that's pretty much what inverse is. You interchange your x coordinates and your y coordinates. After you interchange them, you just plot the new ordered pairs, and then we're going to connect the points. Okay, so again, choose points, interchange x and y, plot the new points, connect them, and voila, you're going to be done. That's going to find the inverse. So let's go ahead and try this one here. So here they give us a graph, right? So this is a graph and they're telling us to find the inverse. So remember, step number one, we're going to choose important ordered pairs. By important, I mean these obvious ones, right? There's 4 obvious ordered pairs. If you want to get all crazy, you could choose more ordered pairs, right? You could choose one here, maybe one here. But I'm just going to do these 4 that were given to us. So the first thing I do is that I make the order, I not plot, right? But I write down the points that are plotted. So for example, if you look at this one, the way you say this is -3, -6. So that's my first ordered pair. And then I just keep on going in order, right? So the next one in line is 2, -1. The next one is 5, 0. This one is 7, 4. So I choose 4 ordered pairs. Now I'm also going to make a little note here so I don't forget. This is the ordered pair that's an open circle. All the other ones are closed. So I just make a little note. So when I plot the new points, I remember that this is the one that's supposed to be open. Okay, the next step according to the last slide is now we're going to interchange our x's and y's. So pretty much all you're going to do is that all of these x values are going to become y values and all of the y values are going to become x values. So look at that. That's all I did. So instead of -3, -6, now I'm going to have -6, -3. And if you notice, we did the same thing for all of these. Okay. Please remember the signs don't change. We don't change signs. We don't make positives, negatives, and negatives, positives. None of that. All we did was just interchange, which is flipping the x and the y. Okay. Now, once we have these points, super easy. Now all I have to do is just plot those, connect them, and that is my inverse. So if you notice, now the new point, which is -6, -3, is right here. -1, 2 is right there. 0, 5 is right here. And then 4, 7 is right here. And then if you notice, remember the open circle is still an open circle. So this one is still an open circle. And all the other ones are still closed. And of course, you connect them in order, right? This one was connected to that one. This one was connected to that one. And then that one's connected to that one. Okay, so you have to follow the same order that we followed over here. So if you notice, I went in order. And then over here, of course, I still went in order and I connected them in that order. So hopefully I didn't lose you here, but again, it's super easy. You just choose the points, flip them, plot the new points, connect them, and you're done. So this right here is the inverse of this one. And again, we were only able to do that because this one is 1 to 1, if you remember the definition we just went over. All right. I think that was pretty simple. So now we're going to go into actually finding the inverse of a function. So this is where things might start getting a little crazy. So now I'm going to give you a function, like an equation, and you're going to have to find the inverse of that. And these are the steps we're going to follow. So the first thing you're going to do is if I give you a function that starts with f of x, the first thing you're going to do is get rid of that f of x and you're going to replace it with a y. So we're going to replace it with a y. Second thing, just like we did on the last slide, we're going to interchange our x and our y. Of course, not coordinates or ordered pairs, but actually the variables. Variable x is going to take place of the variable y and vice versa. After that, we're going to solve for y by having all of the terms with a y on the same side of the equation. Again, we're going to have to solve for y, and in order to do that, everything that has a y has to be on one side and everything that doesn't have a y on the other. Once we do that, once we solve for y, then at the end of the day, we're going to replace the y with not f of x, but f with a little -1, and that represents inverse. So this represents the original f of x, and this one represents f inverse of x, okay? So that's the way you read this, f inverse. All right, so let's go ahead and practice all of these steps in an actual problem. But before we do that, I want to start with a simple problem because this one looks confusing, but it's actually super easy. So I want you to understand the difference between a function and its inverse. So look at this one. Assume that the function f is 1 to 1. And then here they're giving us that f of 9 is 7. And they're asking you find the inverse of 7. This is a trick question. I just want you to understand the relationship. So this is pretty much what is happening. F of 9 means that when x is 9 equals 7 means that I get 7 as a y. Okay, so this is what this means. That means that if I plug in a 9 on the x, I get a y of 7. Now they're asking you to find the inverse. So I know that the original function, when I put a 9, I get a 7. So when they ask you, hey, what's the inverse of 7? That just means you go backwards. So that means that if I put a 7, I'm going to get a 9. Okay, that is super simple, but I just wanted to make sure I explained that so that you understood the relationship between function notation here and what it means when I ask you for the inverse. Okay, so pretty much inverse says instead of going this way, we're just going to go this way. Okay, so I'm hoping that made sense. So every time they ask you for, hey, what's the inverse of a number here? It's just the original number that you input for x. Okay, as promised, now we're going to try to find the inverse of actual functions. So go back to your notes, right? Step number 1 is always get rid of the f of x. So the first thing we do is that we get rid of this and we replace it with a y. Okay, so that's always going to be step number 1. So if you notice, it's exactly the same thing. The f of x became y. After this, remember, step number 2, you interchange your y and your x. So this is what we get. Okay, so I'm going to make sure that you understood that part. So every time you see a y, we notice I replaced it with an x. And every time you see an x, I replace it with a y. Okay, that's always going to be the first or the second thing we do when we're trying to find the inverse. If you notice, the f of x became y, and then I interchanged the x and the y. Now, from here is where it starts getting fun, and you're going to have to do some math work in order to solve this problem, because the next thing is that you're going to have to solve for y. In order to solve for y, it just means you're going to have to isolate the y. So the y is on this side. There's a 2 and there's a minus 5. I'm going to have to leave the y by itself. So I'm going to get rid of the 5. The way we do that is that the 5 is going to come to this side. Okay, so I'm going to have x plus 5, and I'm going to have 2y on this side. And then pretty much we're almost done, because how do you leave y by itself? Well, we get rid of the 2. How do I get rid of a 2? If they're multiplying, I do the opposite. So I divide by 2. But of course, when I do to one side, I do it to the other. And then look at that. The y is now by itself. So this is what I get. All right, so y equals this whole thing divided by 2. When you have a variable and a number, you just divide by 2 and you leave it like that. You cannot simplify. Okay, and then what is the last step according to your notes? Once the y is by itself, I come back, I erase the y, and I replace it with f inverse. And what do you think? That's pretty much all we're doing. So again, this is your original function. Oh my goodness, just pretend I underlined it, and I did it worse. I'm sorry about that. So just pretend I underlined it. That's the original function. And then what you get here at the bottom is what we call your inverse. Okay, so this is the inverse of that. Yeah, pretty much. And if you notice, if you want to play around with it later on, the ordered pairs for this one are the same ordered pair for this one, but of course just flipped, because that's the definition of an inverse. Okay, we're going to continue. We're probably going to do like 4 more examples on inverses, but they're going to start getting a little more crazy. So let's go ahead and try this one. So now we have an exponent in there, and the reason why we're doing this one is just so you know and you practice how to get rid of exponents. So again, same thing, right? First thing you do, get rid of this. We're going to replace it with a y. So this becomes y equals 2x to the 4th minus 11. And then from here, remember the next step, you interchange. So the y became an x, 2x to the 4th became 2y to the 4th, and then the 11 is still there. Okay, so if you notice, nothing changes, only the x becomes y and the y's become x's. Now, the next thing you're going to do is, remember, you have to leave the y by itself. So we already know how to do this. We're going to have to get rid of the 11. So I'm going to move that 11 to that side. So I'm going to have x plus 11 equals 2y to the 4th. Hopefully we're okay up to there. Now, please do not get rid of the 4th yet. We have to get rid of the 2 first. So first get rid of any number that's in front of the y. So just like we did on the last example, we divide both sides by 2. And like I told you, this stays like that. These cancel out. And that's how I got this right here. Okay, so x plus 11 over 2 equals y to the 4th. Now, the last thing you're going to do, because technically you only have one more thing to do, right? In order to leave the y by itself, you have to get rid of this 4. So make sure you put this on your notes in case you didn't know. In order to get rid of an exponent, the opposite of an exponent, it's a root. So in order to get rid of a square, we use a square root. In order to get rid of a cube, we use a cube root. Now, in order to get rid of an exponent of 4, we have to do a 4th root. So pretty much you just use the same example, the same number. So if this would have been 100, we would have done a 100th root. But of course, what you do to one side, so I'm going to do the fourth root of this. Fourth root means has to have a little 4 right there. But what I did to the right side, I have to come over here and do it to all of the left side. Now, like I told you, a fourth root and a 4 power cancel out, leaving me with just y. And then on this side, don't worry about it. Just leave it the way it looks, right? So this becomes the fourth root of x plus 11 over 2. And look at that. Since the y is by itself, that is our answer. But of course, we know we have to rewrite the y as f inverse. Okay, so again, the whole point of this one was just for you to practice how to get rid of a fourth exponent. Again, if it would have been in the 7, it would have been the 7th root on both sides. All right, let's go ahead and keep on practicing. Here we have another one. Now we have a fraction. So again, it's the same thing. They're asking us for the inverse. We know the steps, right? Step number 1, get rid of that, replace it with a y. So it becomes y equals 2 over x plus 11. Second thing we do is we interchange. So this y is going to now become an x. And this x now becomes a y. Okay, so hopefully we're good up to there. If for some reason you see one of these problems on the test or on an assignment, you don't know what to do, at least do these 2 steps, right? You'll get some points for that. Super easy. You just remember this becomes y, and then we interchange the y and the x. Now, what in the world do we do? Again, we know we have to leave the y by itself, but there's a 2 and there's an 11 we have to get rid of. And there's this huge fraction in the middle. Just remember, when you have a fraction, you always multiply everything by the denominator, and that's how you get rid of the fraction. So I'm going to multiply this whole thing, I'm sorry about that, there we go, by the denominator, which is y plus 11. And remember, that's how you get rid of fractions. But what I do to one side, I have to come and do it to the other side. So if I do it over here, I'm not going to write it down, but because I have it over here, so it's going to be x times y plus 11. And then on this side, these two cancel out because they're exactly the same, and I'm just left with 2. Okay, so I'm just going to take a 10-second break here just so you understand what happened, right? So again, let me go ahead and erase all my mess. When you have a fraction, you multiply both sides. So I'm going to put it over here, this side and that side, by the denominator, which is y plus 11. So I multiply this side by that, this side by that. These two cancel out, leaving me with 2. And then on this side, y plus 11 times x. Okay, so hopefully you were able to follow me up to here. All right, now on the left side, I have parentheses. How do we get rid of parentheses? Well, there's something outside, meaning I have to distribute. So x times y gives me xy. X times 11 gives me 11x. And then, of course, on the other side, I'm just left with a 2, right? Okay, from here, remember, we're trying to leave the y by itself. So this little thing here, the y is now on this side. I have to leave it by itself. So let's go ahead and get rid of this 11x. Since it doesn't have a y, we're going to throw it to that side. What happens when something is moved to the other side? It becomes negative. So I have xy here. I still have the 2, and the 11x became negative 11x. All right, you guys, we're almost done. We have a y. We have to leave it by itself, so I have to get rid of the x. What's happening to the x and the y if they're next to each other? They are, okay, just pretend that's a dot. They're multiplying. So how do I get rid of it? Of course, I do the opposite of multiplication, which is division. So I'm going to come over here and divide this by x. What I do to one side, I do it to everything on the other side. So look at that. So that means I'm just left with y equals, and remember, I do it to everything on this side. So I'm going to divide the 2 by x, which I did here. And then I divide the 11x by x, which I did here. Okay, hopefully you followed me through that. Again, we're used to writing it like this. That's okay. But we can also write it as 2 over x, right there, minus 11x over x. Okay, and then of course on this side, these two cancel out, leaving me with just the y. Okay, the next thing we have to do, and this is just the final thing, right? 2 divided by x, nothing cancels out, so it just stays as 2 over x. Now here we have an x over an x, so those actually cancel out, leaving me with just minus 11 on this side. Okay, so I am going to warn you, right? Up when you're in this step, make a little note. You cannot cancel these x's out because on the top, there's two things. So you have to divide both of them by x, which is what we did here, right? The 2 divided by x separately, and then the 11x divided by x. All right, so look at that. We left the y by itself finally, so we're done. But again, remember, correct notation. You erase that y and you write it as f inverse. Okay, so again, don't get scared by this. This is just a notation saying, hey, this is the inverse of the original product. All right, let's keep on practicing. Okay, now we have a root. So again, I'm going through every single scenario possible. So in case you encounter different kinds of problems, you already know how to solve them. Okay, don't let this freak you out. We already know how to get rid of roots. Remember, squares and square roots are opposite. Cubes and cube roots are opposites of each other, and 7 and 7th roots are opposite. It's always the same number. So let's go ahead and try this one out. Again, we already know. First step is rewrite this as y. So y equals the cube root of x plus 2. Second step, the y becomes x and the x becomes y. So this is how we get up to this step, right? We have x equals the cube root. Now it's y plus 2. All right, now we have to leave the y by itself. Again, there's a 2 we're going to have to get rid of, and then there's this little cube root we have to get rid of. Now, what do we get rid of first? We have to get rid of the cube first, the cube root, because the 2 is underneath. I can't do anything until I get rid of the root. Now, we already talked about this. How do I get rid of a cube root? I do the opposite. When you have a root, you do an exponent to whatever number is here. So I'm going to cube this. Of course, when I do to one side, I have to come and do it to this side as well. Okay, so I'm going to have x cubed on this side. The cube root and the cube cancel out. So I'm left with x cubed on the left. And on the other side, I'm just left with y plus 2. Okay, so again, now you know how to get rid of roots. Super simple. Now, in order to leave the y by itself, all I'm going to do is just throw this 2 to the other side. And that's how I get x cubed minus 2 equals y. Okay, this is your final answer already again, but in order for it to look pretty and in order for you to get full credit, this y is now replaced by f inverse x, and then your answer x cubed minus 2. Okay, I don't care if you notice that on this one, the y ended up being on this side. I don't care. When you have an equal sign, you could put the y on the front and this on the other side, and everything stays the same. Of course, just don't forget the y is replaced with f inverse. All right, let's try one more of these. Okay, look at this little monster. This one has a fraction. It has 2 x's. So be very careful with this one, okay? So this one, I'm just going to warn you, it's going to be some long work, but just make sure you follow along with each step. So again, we already know the first step, right? F of x is going to become y. Okay, so I have y equals negative 4x plus 4 over negative x plus 2. What is step number 2? The y becomes x. And now be very careful. There's 2 x's. So guess what? Both of those x's are going to become y's. Okay, so like I mentioned earlier, when you interchange the x and the y's, that means that all the x's become y's and all the y's become x. So if you notice, just take a second to understand what happened. Everything stayed the same, but this y became x and these 2 x's became y's. All right, now we have a fraction. You know how to get rid of fractions, right? When we have a fraction, we multiply both sides by the denominator. So I'm going to come over here. I'm sorry, it doesn't fit, but just pretend it's here. So I'm going to multiply both sides by negative y plus 2 because that is the denominator. Remember, when you have a fraction, always multiply by the denominator. Okay, and I'm going to apologize beforehand because this is going to be super messy. Just pretend you understand, right? Negative y plus 2. Oh, there you go. Not bad. Again, you do it to both sides, so don't panic. This is going to cancel out, leaving me just with negative 4y plus 4, which is right here. And then on this side, I'm going to have negative y plus 2 times x, which is right here. Okay, and that right off the bat looks so much prettier because we don't have fractions, right? So we got rid of the fractions. Now, what in the world do? We have to, remember, to get rid of parentheses, you distribute. So x times negative y gives, oh my goodness, gives me that negative xy. X times 2 gives me that 2x. Okay, and then this on this side just comes along. I didn't do anything to it. All right, okay, hopefully you're still okay, right? So we had an ugly fraction, we multiplied both sides by the denominator. Over here, of course, we have to distribute because when you multiply times the denominator, you put parentheses. Okay, so hopefully you're okay up to here. Now remember, step number 3, we're gonna have to solve for y. But look at this problem. How many y's do we have? We have 2. We have one on this side and one on the other. It's gonna be impossible to solve for y if they're on 2 different parts of the equation. So what we're gonna have to do next is put everything that has a y on one side of the equation and everything that doesn't have a y on the other side of the equation. So this is what we're gonna do. If you notice, let me go ahead and just erase this real quick. This one has a y, so it stayed here. This one has a y, so it's gonna join this one. It's gonna come to this side. But since it's negative, when it came to this side, it became a positive 4y. Now on the other side, I'm gonna have everything that doesn't have an x. So the 4 stayed there, so it's gonna be a 4. And this 2x doesn't have a y, so it's gonna have to go to that side to join the 4. Of course, since it was positive and I moved it to the other side, now it became a negative 2x. Okay, so again, make a little note of that in case you think you're gonna get confused in the future. When you have multiple y's, like on this one, you have to make sure all the y's are on one side and everything that doesn't have a y on the other. So this is where we ended up. Now here's another issue. We have 2 y's and I cannot combine them because they're not like terms. This one has an x and this one has a 4. So what we're going to do in order to make those 2 y's into just one y, we know a magic trick we have covered before. We could factor out the y, right? So these two have a y in common, so I take it out. And if I factor out the y, I'm going to be left with negative x plus 4, which I put in parentheses. And then look at the magic we just did. The 2 y's suddenly just became 1. We only have 1 y to worry about now because I factored it out and I was just left with this. Of course, on the right side, I still have the 4 minus 2x right here. Okay, and hopefully you understand why we did this because look at that. Now I just have to leave this y by itself. There's this huge thing bothering it, but they're multiplying. So how do I get rid of that huge thing? I just divide both sides by it. So I'm going to come and divide all of this by negative x plus 4. Of course, what I do to the left side, I have to come and do it to all of the right side. So negative x plus 4. And now that's super cool because look at that. Now this cancels right here. These two cancel out, leaving me with finally just the y, which is right here. And you don't even have to worry about this ugly thing right here, but you could just rewrite it, right? So I have 4 minus 2x on the top, negative x plus 4 on the bottom. And look at that, we survived. That y is finally by itself, indicating us that we're done with the problem. Of course, to make this pretty, now I have to just rewrite that y as f inverse. And there you go. This whole mess is the inverse of this one. And don't try to figure it out just by looking at it, right? Because we notice we have the same numbers down here, but there's no way to just be like, oh, I'm just going to flip this one and change the sign of this one. No, you have to go through the math because that's the procedure. You have to follow through. All right. Okay, so I think that was enough for those. We're going to go ahead and quickly talk about one more thing here. When we talk about functions and their inverses, there's a really special relationship between domain and range. So the domain of an original function becomes the range of its inverse. It's pretty much just saying, hey, the x and the y's interchange, just like we've been talking about. But just so you could know, domain and range have the same relationship. And then, of course, the range of the original function becomes the domain of its inverse. Okay, so make sure you have this on your notes because we're going to be tackling one last problem, and they're going to be asking us for domain and range. So we have to understand the difference between those. So again, the domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. Okay, in order to tackle the last problem, we also have to know how to find the domain and range of square roots. I could guarantee you this is going to be coming up in a test. So domain and range of a square root, this is what you're going to do. In order to find the domain of a square root, we are going to have to look at the radicand. Radicand is just a fancy name for whatever is inside the root, right? So whatever is inside here is what you call the radicand. So what you're going to do is you're going to look at that. You're going to set whatever is in here greater than or equal to 0, and then we're going to solve it. That is how you find the domain. If you want a reason why, is because remember, you cannot find the domain of a negative number. So that's why anything that's in here has to be positive, meaning it has to be greater than or equal to 0. It could be equal to 0, so it could be positive or equal to 0. So that's what we're going to do. Okay, if that makes no sense, don't worry, we're going to be doing an example right now. So that's how you find the domain of a square root. Now, the range of a square root is always 0 to infinity, including the 0. Because if you remember from the picture, we've talked about the parent functions, the square root looks like this. So the range is always from 0, right here, up, right? It's always positive. So that's why the range is 0 to infinity. Of course, this is only the range of the original square root. If we start modifying it, if you remember transformations, if we start moving it up and down and reflecting, of course, it could change. But just remember for right now, the range of the original square root is always 0 to infinity. Okay, so we're going to put this to practice in the next example. So if you don't understand this, that's okay. Just make sure you have it on your notes. Okay, so this is going to be the last example for our video. It just has several parts though, so let's go ahead and just start. So they're giving us a function, right? The function is the square root of x plus 17. And they're telling us to find the domain and range of f of x in interval notation and graph it. So we're going to have to find the domain of this, we're going to have to find the range, and we're going to have to graph it. So let's go ahead and start by figuring out the domain. So if you look at the notes, in order to find the domain of a square root, we look at the radicand. Remember, radicand is everything inside the root. And we just have to set it greater than or equal to 0. Now, once we do that, we're going to solve this. So let's go ahead and start here. I grabbed the x plus 17. I made it greater than or equal to 0. We don't care about the root right now. Remember, we just care about the radicand, which is whatever's inside. Now, you guys have a little practice on this already. How do I solve this? Well, I'm going to move this to the other side. So it's going to become x is greater than or equal to negative 17. Remember, I just subtracted, so the sign stays the same. And look at that, we're already done. That's our domain, but they want the domain in interval notation. So in order to make this in interval notation, remember, you don't have to do this, but it helps me to do it. The negative 17 is right here. When we have the symbol greater than or equal to, that means I shade to this side. Greater than means greater than negative 17, so to that side. Remember, it's kind of like an arrow, it's pointing that way. Now, equal to means I use the closed circle. And this means in interval notation, where does the shading start? It starts at negative 17. Since it has an equal to on the bottom, it means I'm going to use a bracket. Comma, where does the shading end? Well, the shading ends all the way over there, which is at positive infinity. And infinities always go with parentheses. So there we go. We found the domain. This is the first time you guys find the domain of a square root. But just don't panic. Anytime you have a square root, this is as simple as it's going to get, right? You just remember, look at the inside, set it greater than or equal to 0, and then solve. Okay, so we have this done. We did the domain. Now, what's the range of this? So that should be a trick question because on the last slide, the range is 0 to infinity, right? Again, because that's always going to be the domain of a square root. If there's a number out here at the back, I'm going to warn you, the range is going to change, but we're not going to worry about that yet, okay? So if there's a number out here, or if there would have been a negative here somewhere making a reflection, it would change, but we're not going to worry about that yet. We're going to cover that later. So for right now, just remember the range is going to be 0 to infinity, including the 0. Okay, so we have the domain, we have the range. Now we're going to have to graph this beautiful square root. Okay, in order to graph this, we are going to choose values that are in the domain. You cannot choose numbers that do not fall here. Okay, if you choose a number that falls outside of the domain, you're going to be in trouble. For example, if I were to choose negative 20, right? Negative 20 is not here. If I were to choose negative 20, I add 17, that gives me a negative number. I cannot find the square root of a negative number. So that's why the domain exists. The domain tells you what kinds of values you could input for x. So the domain says you could choose values that are negative 17 or to infinity. So let's go ahead and start at negative 17. So I'm going to choose negative 17. I am going to put the negative 17 in the x and see what answer I get. Okay, so I put the negative 17 in here, right? So instead of x, I put negative 17 plus 17. So what does that give me? Negative 17 plus 17 is 0. What's the square root of 0? Well, 0. So there we go. We have our first ordered pair. Again, in order to graph this, we need points so we could connect. So that's why I'm doing this. We're going to come up with random points. So I put negative 17 comma 0. That's my first point. Now, let me make this clear. You guys could choose whatever numbers you want. From negative 17 till infinity. You have infinite amount of numbers you can choose. Now, to make our life easier, I want to choose numbers that when I put them here and I add 17, I could get a number that's going to have a perfect square root. Because for example, if I choose 1 and I do 1 plus 17, that gives me 18. But does 18 have a perfect square root? It doesn't. I get a decimal. So what I'm going to do is I'm going to choose pretty numbers. So look at this. I'm going to choose negative 1. And again, this is the reason why I chose negative 1. Because what is 17 minus 1? It's 16. And 16 has a beautiful square root. So that's why I'm choosing negative 1. So negative 1, I put it in here. Negative 1 plus 17, which is the same thing as 17 minus 1. I get 16. And the square root of 16 is 4. So there we go. I have my next ordered pair, which is the number I chose and the answer I got. Okay, let's see. Can you think of another number that I could put here? So again, there's infinite amount of numbers, but the next number I know that 25 has a perfect root. So what can I add to 17 to get 25? That gives me 8, right? So that's how I chose this number. Because again, when I do 8 plus 17, it gives me 25. And the square root of 25 is 5. So there we go. Then we got our third point. Okay, so again, you don't need that many points. I'm just going to do 3 points, and then we're going to graph those, connect them, and boom, we're going to be done with our graph. So here we go. These are the 3 ordered pairs that I found. And then I connect them, right? So 17 comma 0 is right here. Negative 1 comma 4, 8 comma 5. And you guys know that roots look like this, right? Remember, if you look at your notes for square root parent functions, the graph looks like that. And of course, this one's just shifted 17 units this way. Okay, so look at that. We found the domain, we found the range, and we found the interval notation. Of course, this lesson is called inverses. So the last thing we're going to do is just find the inverse. So find the inverse of f of x and the domain of the inverse. So this is where it starts getting interesting. Okay, so let's find the inverse. Again, it's the same thing we've been doing all this lesson. So first thing we're going to do is f of x is going to be rewritten as y. Y equals the square root of x plus 17. Now I interchange the y and the x, so this is going to become x equals the square root of y plus 17. And then we solve this, right? So in order to leave the y by itself, I have to get rid of a root. Remember, if it doesn't have a number, it means that it's a square root. It's an invisible too. So we know that to get rid of roots, I put an exponent to the same number that's here. But what I do to one side, I do it to the other. So the square root and the square cancel out. So I'm just left with y. I'm sorry about that. Pretend that's a plus. Plus 17. And then the x squared on this side. Okay, so again, the square and the square root cancel out. This is still y plus 17 here. And then we have x squared right there. Okay. Now, what do I do next? We're just one step away. In order to leave the y by itself, I'm going to have to move this 17 to that side. Of course, if it's positive, when I move it to that side, it becomes negative. So again, I'm sorry about that typo. That should be a negative 17. Okay. And then that's it. We have the y by itself. So that means that my inverse, and again, I'm pretty sure there's going to be a typo there, is going to be x squared. So this is how I'm going to know you actually watched the video. Make sure you fix that there. It's going to be y equals x squared minus 17. So that's going to be my inverse. Now, if you notice, they're asking us for the inverse, which we already have here. It wasn't that bad because we've done a bunch of those problems by now. But now they're also asking us for the domain of the inverse. What in the world is the domain of this? It's again a trick question. Remember, the domain of this is actually going to be the range of the original one. So if I go real quick a couple slides back, we had said that the range of this original function was 0 to infinity. So that means that that's going to be the domain of the inverse that we just found. Okay, so again, if I lost you there, just remember the domain of the original one becomes the range of this one. And then the range of the original one became the domain of this one, which is the one that we're asking us for. Okay, so again, make sure you have that on your notes. You're going to be seeing a couple of these problems. Again, if for some reason I lost you or you need additional help, just make sure to come and let me know.